So today, excuse me, today we're going to look at ways we can kind of use arrays in C++. So kind of some of their uses and how we wind up using them. Last class we looked at how do we create them, how do we store data in them, how do we get data out of them. But we're going to look at some kind of additional little things today. And these are by no means a full complement of everything that you can do. This is just what it is that is possible, so we can move forward with this. So one of the things that we have is, because arrays are a collection of data, collection of information, it is pretty common that we need to search through them. So I have an array and I have information, and I need to just kind of search through it, see if I can find some information. Now, in some languages, and if you remember going back to Python with the list, um, they have some built-in tools to help you work with that. C++, because it is decidedly designed one older, C++ is probably about 20 years older than Python, maybe a little bit older than that. It didn't, the computers weren't as powerful, and so they said, we got to make this really, really efficient as far as the language goes. And so we have to build those types of features. And that's a good, bad thing. They're not difficult, as we're going to see. I'm actually going to show you two different ways to search for your list, or through your array. Sorry. So the first one we're going to look at is called a linear search. And a linear search is literally, you just take like a for loop, and you say, I'm going to go through my loop, or through my array, looping at each individual item, and determine if I have found my item. If I have, then I can specify that I found it. Maybe I need to specify this is the index I found it at. However that's going to work. And if we're honest, a small array, I've got 10 items, 100 items, a linear search is fine. It's very inefficient, because you got to search through every item. But at the same time, if you get a small array, especially with a modern computer, it's really not that big a deal. Where you get into a bigger problem is as this array grows in size. So we move from 100 items into 10,000 items. Now that's a lot more searches I have to perform, potentially every time. So it's going to take some time. And it might just be a few seconds. I might say, oh, this is only 20 seconds. How big can that really be? Well, if I was doing this as some sort of automated system software, let's say that I was using this as a kind of quote unquote search engine, um, to list through all my products. And I had 10,000 products on a website, and I had people that were doing it every minute or two, and it was taking me 15, 20 seconds. That really adds up. And you're not going to want to sit there and wait for 20 seconds on a website while it finds your results. No one wants to go through that. So uh, we need to find a better way. But this is a real simple and easy way to do it if you only have a little bit of data, or if your data is unsorted. And that means that it's very randomized. You don't know how that data is positioned. So if I have numeric data, I might have 3 and 12 and 85 and then 6, and all those numbers are not in any particular order. And so sometimes I'm stuck with it. Um, but if I can get around it, away from it, I'll want to. Okay, so this is real simple. You can kind of see it there. We don't need to kind of work through it, um, but it gives you a way that you can kind of look at it. Okay, if you do want to go through this, you can see how this example would work. I've got some sample code here. You can copy and paste that in. It returns a Boolean value, and then you can, depending upon what the Boolean value specifies, you can do something such as, um, you know, write an if statement or anything like that you need to. Additionally, another way, instead of using that Boolean value that you will see from time to time, is it will return an integer. And that's to return a value that is based upon what index in the array it was. So that's another pretty common little tweak on this. Um, you might say, well, what happens if it's not found? And that's a really good, obvious question. And the answer for something like that is a lot of times you'll return like a -1. So because I can't be an index of -1, if I'm -1, that means I haven't found it. If I'm a positive number, then that means that I have found, or 0 or positive, that means that I've found that value in my array. So that's like just a little tweak on that you'll see periodically in how it's being used. Okay, so just kind of something to look at as far as that goes. Um, what I want to do is I want to look at the binary search. So this is a little bit more complicated, but it's much more effective, and it's much more faster. Um, and the reason why is because of how it works. And we'll go into more detail of how it works, and we'll see examples of this um, if you take a future class, something called Introduction to Algorithms. But the basics of a binary search says that I have an array and my array has to be sorted. That is a key component to this, is that your array has to be sorted. If my array is sorted, then what it does is it says, well, I'm going to go through my array, and my first step is I'm going to say, what am I looking for? And then I'm going to look in the middle of my array. And it's called a binary search because every time we test and check to see have we found our element, we're going to eliminate half of the remaining array if we don't find it. So this is kind of similar to the old game, pick a number between 1 and 100. And so no one goes, well, is it 1? Is it 2? Is it 3? Is it 4? They just, what do? You first go, was it 50? And then someone says, was it higher or lower? Well, the reason for doing that, the reason why you pick 50 is I can eliminate half of my possible options right away, right off the bat. And guess was one guess. So now instead of having to guess 100 times, I'm down to a maximum of 50 times. Well, if I then find the middle again, okay, so I ask someone to guess and they guess 50, and I say it's lower. And so what do? You go, oh, well, is it 25? Well, if it's 25, you found it. If it's not, you go higher or lower. You go, oh, it's higher. So it says, huh, okay, so it's between 25 and 50 now. Well, I've eliminated 3/4 of my possible options with just two guesses. And that's how the binary search works. Very efficient. So let's look at how it kind of does this. It's an interesting little process. Excuse me. Interesting little process here. Let's just kind of take a look and see what it does. So I have a um, binary search function here. I pass an array of items. They're very generic items. Okay. I have a integer for high or the max value if you, or my elements if you prefer, and then what I'm searching for. Okay, so those are the three things that we're going to pass into this function. I'm going to have a low value, and my low value is my lowest index. So I have high, which is my high index, low, which is my low index. My low index is always going to start at 0 because I have a 0-based array system. And then I have a midpoint. Then I'm going to just go in and real quickly, essentially walk through this with a while loop. Okay, so while low is less than high, what I'm going to do is I'm going to calculate the midpoint. My midpoint is low plus high, and divide by 2. So if I have 0 and 100, add those two together, it's 100, divide by 2, that's 50. That's my midpoint. And then I just go through a process, okay? If my search for item is less than my midpoint, I'm going to set my new midpoint. My midpoint is going to be my new high point is going to be what my midpoint was minus 1. I don't need to check 50. That's not relevant. Okay, I'm going to check 49. That's the highest that it could possibly be. If it does match, I have a match. I set what my return value is true in this case. I could, like I said, specify what my index is, do different things like that. I'm just looking to see if I found it at this point. And then I set my high to be -1. You might say, well, why did I set high to -1? Well, remember, my while is while low is less than high. Well, if my high is -1, my low, the lowest it could possibly ever be, is 0. Therefore, low is no longer less than high, and I'm going to exit out my while loop. Okay. If you look at the example they give you in a book, they do it a little bit differently. I don't like the way they do it, is they put a return statement in the middle of my while loop. That's not real clean code. If you remember when we talked about functions, we talked about how we really only want one entry point into our function and one exit point. That means only one return statement. That's why we're using a return value, and then down here we're going to return that value. So that's the reason why I did it like that. Okay. If our search for item is not less than items at the midpoint, if it's not equal to what we are at the midpoint, then clearly it's greater. And so I'm going to take the low and I'm going to increase its indexing value up to the midpoint, once again, +1, because I obviously can't be that midpoint. We already tested that. So therefore, low is going to be the next item up. And then we're going to go through this process again. Okay, we're going to recalculate our mid and go through this process. Each time we cut the remaining elements down by half. If I've got 100 items, I believe it winds up being about 7 tests on average is what it winds up being. Uh, Sometimes it's going to be more, sometimes it's going to be less. It could be 50 that midpoint, in which case you can get on the first test. But on average, if you go and do this 100 times type thing and finding elements, on average, it's going to be about 7 tests. Compare that to if I had a linear search and I'm just going and stepping time by time by time. If I did that on average, it would be about 50, okay, for an array of 100 elements, okay? It'd be that halfway point. Sometimes it's before, sometimes it's less. Worst case scenario, it's 100, okay? That's horrible. That's a worst case scenario. But your average is going to be about 50 elements. What's interesting is if I go up to 1,000 elements, I go from 100 to 1,000, 10 times as much. If memory serves right, you're around like 13 tests. You'd only get double number of tests, even though you went up by over 10 times the amount of items. And it all has to do with the fact that every time you do it, you're cutting it in half. So if I have 1,000 items, I check at 500, I knock out 500. Then I go 250, I knock out 250. Then I'm at 125. 3 more tests, I'm down to almost the same number of tests I'd have as if I had 100, because I'm down to 100 elements. So even though I increase it by 10 times the size, it's really only 3 more tests in order to find my result. And that's what makes the binary search so efficient and so effective, is I can add larger and larger and larger sets of data. We actually did this in another class where we did some tests. And we happened to do that one in Python, but we were putting 50,000 elements and trying to find it. and we were trying to time it. And our biggest problem that we'd have is that it would find the element so fast that we couldn't get a time out of it. It was showing the same time. It was just a few milliseconds, even though we had like 50,000 elements. I think it took us over 250,000 elements to get there. So that's how effective, that's how efficient and effective the binary search is for us. It really makes it a good tool to use, a good one to learn if you want to go through this. Now, like I said, the downside is that this array has to be pre-sorted. So if we have an array that's not sorted, then I don't know if I'm higher or lower. I just know that it's not that midpoint. And so I got to go through the process. So the next thing I want to show you how to do is how to do how to actually sort our data. We'll actually go through this as an example. However, I just got the notification that we are down to 10 minutes left of this video. Remember, we only get 40 minutes. So what I'm going to do is I'm going to exit out of this real quick, let it download that MP4 file so I can upload to YouTube, and we'll restart this in just a couple minutes if that's okay with everyone. But before we do that, does anyone have any questions with the binary search? Let me bring that back up. Any questions with the binary search or how that works? Okay. All right. I will see you guys. It's going to take a couple minutes for that file download I found out from last time. Um, so I will join back as soon as that's done, and I will see you all then. So join back in just a couple minutes.